Hi, welcome you all. So any doubts anybody has? So are you all set for tomorrow's quiz? Yeah? Yes or no?
Not fully.
Yeah, but still there's time, right? By that time, possibly you will get fully prepared. All right, so in the quiz, you can use any stuff you want, right? Any stuff under the sky, any course material you want to use. You want to browse through web, you can browse through web. You can use any material you want, right? But no collaboration in between, right? That I'll not tolerate. But anything, any stuff you want to see from anywhere, feel free to refer to it. You can see the lecture notes which I gave. You can look at any stuff which is available on web, anything. No issues with that. All right. Okay. Any doubts anybody has?
So part B of the question number 3 from problem set 3.
Problem set 3, part B of, okay, yeah.
So while proving the sufficiency part, there is
Yeah.
no problem with it, but how to go for the completeness part?
So you see, for completeness, if you see, I did that result about exponential family, right? So try to write down this in the form of an exponential family. So let me just share the whiteboard. So this is problem 3B. So 3B, right? It is beta theta 1, 3B you're saying, right? So your joint PDF, because it is beta, so joint PDF of X, which is X1, X2, Xn, is, let me call this as G theta. Theta is a vector, X1, theta 1, theta 2, because it is a beta theta 1, theta 2, right? So it is product I is equal to 1 to n. Then the density of xi, which is 1 upon beta theta 1, theta 2. Xi to power theta 1 minus 1, 1 minus xi to power theta 2 minus 1. All right. Into hx, this is the range is 0 less than xi less than 1, right? This is what it is. So you can write down this as 1 upon beta theta 1 to power n. Product I is equal to 1 to n xi to power theta 1. Only theta 1 terms for you can keep first together. I is equal to 1 to n 1 minus xi to power theta 2. Then product I is equal to 1 to n 1 upon xi into 1 minus xi, indicate 0 less than xi less than 1. Okay. You can call this as some function of x alone. So this can be written as e to power. I want to write down this everything in terms of exponential. So it is e to power log of this, but log of this is same as theta 1 log of this. So summation I is equal to 1 to n log of xi plus theta 2 summation I is equal to 1 to n log of 1 minus xi, then minus n log beta of theta 1, theta 2. And then this is hx. Is that okay? I have written down, now it is in terms of exponential family, theta 1, theta 2. So if there are two theta's terms, so if theta 1, theta 2 contains an open rectangle in R2, then summation log xi and summation log 1 minus xi would be complete and in fact sufficient also. So let us look at what is the range of theta 1, theta 2. It belongs to 0, 1 cross 0, 1. It contains so many rectangles, not only one, right? It is the parameter space is theta. The range of this theta 1 and theta 2 is 0, 1 cross 0, 1. In fact, this itself is a rectangle and it can contain infinitely many rectangles, right? So contains a rectangle in R2. In R2, which implies that summation I is equal to 1 to n log of xi and summation I is equal to 1 to n log of 1 minus xi is complete sufficient. Now you know that if a function is sufficient, so minimal sufficient, right? So minimal sufficient, because any complete sufficient statistic is also minimal sufficient. And you know that if you have a minimal sufficient statistic, then any one-to-one function of a minimal sufficient statistic is again minimal sufficient. So this implies that e to power summation log xi and e to power summation log 1 minus xi is minimal sufficient. Why? Because if you consider the function g t1 t2, which is e to power t1 e to power t2, is a one-to-one function of t1 t2. Because if you know t1 t2, you can find e to power t1 and e to power t2. And if you know e to power t1 and e to power t2, you can find t1 t2. But what is this? This is nothing but product of, yeah, xi, and this is product of 1 minus xi. Is minimal sufficient. Is that clear?
Yes, sir.
Okay. So a lot of results you can prove through that result which I did for the exponential family, because that gives you sufficient as well as complete, and any complete sufficient statistic is a minimal sufficient statistic, right? Yes, any other doubt anybody has?
Sir, what will be the full marks of the examination?
25, I said, no? So 3 questions, roughly 8 marks. There will be 2 questions of 8 marks and 1 question of 9 marks.
Okay, sir.
You can use any material, right? Your whole lecture notes would be available to you. Whatever you want to use, you can use it. Except that don't collaborate between yourselves. You have to do it of your own. You have to keep your videos on during the Zoom meeting. Everybody has to be present throughout.
So the questions are going to be too much hard. Yes.
Why? No. Questions will not be hard. Questions would be whatever is taught in the class during the lectures.
Okay, sir.
Right. I'll not ask something. Right. So don't bother too much about that. Just be honest to yourself. You don't have to prove your honesty to somebody else. If you're honest to yourself, I feel there should not be any problem. All right. Yes. Any other problem anybody wants to discuss?
Sir, part A of 10.
Part A of 10. So first, let me ask the main problems 1 to 7. Does anyone has any doubt?
So,
Yeah.
Can you discuss problem one?
Problem 1.
Yes, sir.
Okay. So what is happening? I'm not able to. Oh, it looks like my battery of this is gone. And, I don't seem to have. Let me just try it. Let me see. Okay, I have been able to go. Yeah. So the first problem number 1. What is given to you is, suppose T is complete. Of course, if it is complete, it has to be for a family of distributions. Let us say of theta belonging to theta. That is given to you, right? H of T is some function of T, a given function of T. My claim is, so let me call this as Y, is Y is complete, right? That is what you have to prove. Is that clear? Yes or no?
Yes, sir.
Yeah. You have to prove that if T is complete, if you are given any other function of T, that would also be complete. So to prove that Y is complete, what do you have to prove? I have to look at any function psi, and if expected value of psi Y is 0, I have to show that probability that psi Y is equal to 0 is 1, right? So let psi be any function such that expected value of psi of Y is 0 for every theta belonging to theta. Okay? I need to show that probability that psi Y is 0 is 1 for every theta belonging to theta. Is that clear? That is what I have to show for completeness of Y. No, expected value of psi of Y is 0. What does that mean? The expected value of psi of H of T is 0 for every theta belonging to theta. I can consider this as K of T. Psi of H of T as K of T. So where K is a function which is a composition of psi and H. What do you have now? You have a function of T whose expected value is 0 for every theta. I use the fact that now T is complete. What does that mean? That would mean that probability that KT is equal to 0 is 1 for every theta belonging to theta. Which is probability that, what is the KT? Psi of HT. Psi of HT is nothing but psi of Y. And I am done. Is that okay?
Yes, sir.
Okay. Any other doubt anybody has? So for example, to see an application of this result, let us look at x1, x2, xn are IID normal theta 1, where theta is between minus infinity. Is Tx, which is e to power x bar plus 9x bar plus 15 is complete. I'm just showing an application of this result. What would be your answer? Is it complete? Anyone?
Yes, sir, I think.
Yes, sir.
It would be, because in this case, you know that x bar is complete, right? Again, through that result of exponential, right? Because your joint PDF of x1, x2, xn is 1 by root 2 pi to power n e to power minus 1 by 2 summation xi square, then summation xi square minus 2 theta summation xi plus n theta square, right? This can be written as, this I can consume in hx because there is no theta over here, e to power minus 1 by 2 xi square. This also in hx. This becomes e to power 2n theta x bar and minus n theta square by 2 into hx. Hx is 1 upon root 2 pi to power n e to power minus 2. So by that result for exponential x bar, there is only one term coming over here. X bar would be complete and sufficient if theta contains an open rectangle. But theta can be a whole real line. So it can contain lot of rectangles. So x bar is complete sufficient. And by problem number 1, any function of a complete statistic is complete. And what is this? E to power x bar plus 9x bar plus 15 is some function of x bar. So this would also be complete. Is that okay? So in fact, if you look at problem number 4, a lot of result can be used, can be proved using this result, especially about completeness. Right? Yes, any other doubt anybody has? Okay, then let me just come to the doubt. Which problem you were saying?
So number 10.
Number
Part A.
10. Okay, let me just fix my mouse first. Problem number 10, right? Problem number 10. So you have a family of PDFs, which is a finite family of PDFs. F0, F1, and Fk. Each having the same support, right? So each are having the same support. Okay. Prove that Tx is equal to F1 upon F0, F1x by F0x, Fkx by F0x is minimal sufficient, right? Note that this is well defined because all of them have a same support. So F1 by F0 would be almost surely respect to these measures would be well defined, right? Because F0 would be defined in the support of whole of P because they all have a same support. So it is well defined, right? So first type proof is claim 1, T is sufficient. All right. So to show that T is sufficient, I can use the factorization theorem. And by factorization theorem, T would be sufficient if I can write down my any density Fi x as psi of. So my claim is by factorization theorem, if I can write down my Fi x as psi of I, because it may depend on what PGF I'm talking about, T of x into Hx, right? If I can write down like this, I is equal to 0, 1, 2, k, then I'm done, right? So first of all, F0x can be written as F0x. Is that okay? F0x can always be written as F0x. So it would be psi 0. So what should I take at psi 0 of Tx? Anyone? What should be this? It should be 1 because F0x I'm trying to write down as F0x and Hx should be F0x. Is that okay?
So why is this 1?
Because I'm writing down F0x as only F0x. So this psi 0 Tx, for F0, what do you get psi as? Psi 0 Tx. Tx should be a function of F1x upon F0x, Fkx upon F0x. But this is not a function of T1 because there is no, in F0x, there is no F1x upon F2x and so are coming. Is that okay?
Okay, sir.
Okay. What would be psi 1 of Tx?
F1 by F0 x.
Yeah, your voice is very funny.
F0 x.
So basically your F1x can be written as F1x upon F0x into F0x. F0x is Hx only.
Yes,
Right?
sir.
So this can be written as, so this would be how much psi 1 Tx? It is only F1x upon F0x, the first component. So it is only T1x. Is that okay? Into F0x and F0x, F0, you get 5. What would be F2x? F2x would be T2x, right?
Yes, sir.
Psi 2 Tx would be nothing but F2x can be written as F2x upon F0x into F0x. So psi 2x, psi 2 Tx would be Tx. And so on. Similarly, when you go for a psi k Tx, this would be T2x, right? It would be Tkx, right? Why? Because in general, if you look at Fix, right? The reason is as follows. In general, I can write down Fix as Fix by F0x into F0x. Is that okay? I've involved this as Hx, right? Because this is common to all. This is not depending on I. So F0x is same as Hx. And what is this? This is the ith component of this vector Tx. So this is Tix into Hx. And I wanted to write down this as psi of I of Tx, because that is what factorization theorem says. So what is your, so that means this proves that Tx is sufficient. Is that clear or not? Is that clear to anyone? Everyone? You see, I'm
Yes,
just trying to use the factorization theorem. My factorization theorem says that T would be sufficient if my any PD of Fix can be written as psi of Itx into Hx. You see, because factorization theorem, what it says, your F theta x can be written as psi of theta Tx into Hx, right? That is what factorization theorem says. If you can factorize like this, then Tx is sufficient. So here this theta is taking values in the finite set 0, 1, 2, k, right? Because you have either f0, f1, fk. So that means I had to write down Fix as psi I Tx into Hx. If I can do that, I am done. So what I do is I start doing one by one. First, I see how can I write down f0x. f0x cannot be written as a function of Tx. So that means this psi 0 Tx could be same as 1 into f0x. Hx I can take as f0x only. Now f1x, how can I write down this as a function of f1x upon f0x, fk upon f0x? f1x by f0x multiplied by f0x, right? Because that will give you fnx equal to fx. In general, Fix can be written as Fix into f0x into f0x. So in all of them, this f0x is common, which does not depend on I. So I can take that as hx. And for Fix, I wanted psi I Tx. So what is my psi I Tx? Psi I Tx should be a function of these ratios. And I see that Fix is same as Fix upon f0x, which is the ith component of this Tx. So this is same as Tix. T is a vector. So I have been able to write down this as I've been able to factor it appropriately. So by factorization theorem, Tx is sufficient. Does anyone has any doubt in this? Now I have to show that it is minimal sufficient. To show that it is minimal sufficient, what I have to show? It is a function of any other sufficient statistic. So let U be any other sufficient statistic. To show minimal sufficiency of T, we need to show that T is a function of U. Is that okay? Okay. So U is any other sufficient statistic. So by factorization theorem, because factorization theorem is if and only if, there exists a function, let us say M, says that Fix is same as M of I of f theta times the sufficient statistic U of x into kx. K does not depend on theta. I is equal to 0, 1 to k. What does that mean? That means Tx, which is f1x by f0x, fkx by f0x is same as f1x by f0x is same as m1ux by m0ux. and then mkux by m0ux. These m are known, m is a known function. So what does that means? Tx is a function of ux. This is a function of ux. So you saw that T is sufficient and it is a function of any other sufficient statistic U. So this implies that T is minimal sufficient. Does that make sense?
Absolutely.
Okay. Any other doubt you would like to discuss? Have you been able to do the problem 6? Now note that this 10th part B says that if they all don't have a same support, then there could be a problem.
Sir, can you please repeat?
Part B, you see in the part 10th part A, we saw that if they all have a same support, that means their range is same, their where density is positive is same, then F1 upon F0 and Fk upon F0 is minimal sufficient. But in the problem B, I give 3 densities. F0 is positive only on -1, 0, F1 is positive only on 0, 1, and F2 is positive only on 0, 1. Here, F1 upon F0 and F2 by F0 is not minimal sufficient. So result 1 is not applicable because there these F1 upon F0, because this factorization theorem says, if you look at what does factorization theorem says? Factorization theorem says that if I can write down Fi as psi I Tx into Hx almost surely with respect to the probability measures which you are considering. Now here probability measures were F0, F1, Fk. For each of them I can write down like this, right? And there is a reason why it was this thing. So same support was this 7. But in problem B, your P was F0, F1, F2. Tx, what was your F0? F0x was 1. If -1 less than x less than 0, 0 otherwise. F1x was 1. 0 less than x less than 1, 0 otherwise. F2x was again 2x if 0 less than x less than 1 and 0 otherwise. What is your Tx? Tx is F1x by F0x and F2x by F0x. Now here, if you look at the whole range under P, what is the whole range under P? Support under P? It could be -1, 0, 0, 1, so the whole support could be -1 to 1, right? Right? Because some densities it would be -1 to 0, 0 to 1, so there'll always be a density. What is f1x by f0x? Yeah, so this quantity would be if x lies between -1 to 0, what will be this quantity?
So 0.
F0x is 1, so this is 0. And if x is between 0 to infinity, singletons I do not bother about because they are densities, right? They are densities, so single points don't matter. X lies between 0 to infinity. What is this quantity?
So undefined.
Not defined, it is infinity. Extended real value system, it is defined, right? It is
Yes.
0 to infinity. So Tx takes two values. So here when I'm defining T1 upon T0, it basically means if, so here I'm using the convention that A by 0 is infinity if A is positive, right? That is a convention. So I'm dealing with an extended real number system.
Okay, sir.
Right? That is what it means, right? So that's a convention one. So what I have to show? I have to show that Tx is not minimal sufficient. So first I try to show that it is not even sufficient. So to show that it is not sufficient, what do you have to show? Distribution of x given t is equal to t
It's dependent on theta.
Dependent on theta.
depends on
The
f0,
parameter.
f1, f2. It will not be same
F1,
for all
F2.
f0s, right? Is that okay? So let us look at what is the distribution of x, let us say x less than or equal to x, given that tx equal to 0 under f0. You see, if t was sufficient, then this quantity would be same as under f0, f1, f2, because it does not depend on theta. Is that okay? That is what the definition of a sufficiency says. Probability distribution of x given th does not depend on theta. And here theta is either f0 or f1 or f2. Or you can write down theta as 0, 1, 2 also because f theta, right? What does that mean? Your distribution is f0, that means x has a distribution f0. And if x has a distribution f0, tx is given to be 0. Tx is equal to 0, what does that mean? That means
X
yes.
lies between -1 to 0.
So it is under f0x only, right? You see, that means tx is f1 upon x upon f0. So that means what does that mean? That means x is lying between -1 to 0. So what would be this quantity? Because your random variable takes only value between -1 to 0, so this would be 0. If x is less than -1, x is greater than -1, and less than 0, what would be this quantity? So that means your x is f0. F0, your density is -1 to 0. What would be this? X plus 1, right? And for x greater than or equal to 0, this would be 1. What would be probability under 1, x less than or equal to x, given tx equal to 0? Given tx equal to 0, x lies between -1 to 1. And I am calculating probability under f1x, that x lies between 0 to 1. What would be this? Yeah?
So 0 when x less than 0.
0,
X.
0, 1, x is Actually, this is same as, just look at now, this probability under H1, this is same as probability under H1, that x is less than or equal to x, given that Tx equal to 0 means x lies between -1 to 0. Right? What is this? This is same as under P1, x less than or equal to x, -1 less than x less than 0, divided by P of 1 -1 less than x less than 0. Under P of 1, x lies between -1 to 0 is probability 0. Right? This is 0. And what is this probability? Anyone? So this is same as probability that -1 less than x less than x less than or equal to x and x less than or equal to 0. That means x less than or equal to minimum of 0 and small x. So for this probability to be meaningful, minimum of 0 and x should be greater than -1. So that means 0 greater than -1, which is always true, x should be greater than -1. But so this would be only for x greater than -1, right? So if x less than -1, it is 0. So for x greater than or equal to -1, what is this quantity? Probability that x lies between -1 to 1 under H1 and 0. So it is 0 by 0 form. So it is not even defined, right? So it depends on which F1 you are taking. So it is not independent of this theta. P0, P1, they are different for a given Tx equality. It depends on the distribution you are considering. Is that okay? So it is important that they all have the same support. Is that okay? There could be a problem basically here. That is what it is saying. You'll end up with Tx equal to 0 because Tx can take value 0 or infinity, right? If x lies between -1 to 0, it takes value 0, otherwise infinity. And I see if I consider the distribution of x given Tx equal to 0, then there is a problem. Because distribution of x given Tx equal to 0, what does that mean? That means your distribution is only F0. Is that clear or? So this does not depend, this depends on theta. When you're considering P0 and P1, you're not getting the same thing. Just write it down properly. That's all. Any other doubts anybody has?
Sir, in this case, how can we find the minimal sufficient statistic?
In this case, it will be difficult. I don't see any straightforward way to look into it, right? So the minimal sufficient statistic would be your x itself.
Okay,
There is
sir.
no further reduction possible from the x. So normally when supports are different, finding a minimal sufficient statistic is not that straightforward. Because x is sufficient. Now you try to show that any other minimal sufficient statistic would be a function of x. There is no other way you can do it. Any other doubt? Yeah, any other doubt anybody has?
Sir,
Yeah,
sir, I had a doubt from the lecture note example.
yeah, tell me which example?
Sir, the last example on page 23.
What does it say? Can you just read it for me so that I don't have to go back to the lecture notes? Can you just read it for me?
Yes, sir. It says let x1, x2, xn be IID with PMF f theta x equals 1 by theta if x belongs to 1, 2 to theta
Right.
and 0 otherwise. We are required to show that the family f theta is complete.
Okay.
Uh,
I think that is one of the problems also, right? It is problem number 7. Right? Your f theta x
yes, sir.
is given to be 1 by theta if x equal to 1 to theta and 0 otherwise, right? That is what problem number says, because it is uniform distribution of the set 1 to theta. I have to show that it is complete, right? And what is my theta? Theta can take value integers. Theta takes value positive integers 1, 2, 3, so on. So what I have to show? So let psi be such that expected value of psi x is 0 for every theta belonging to theta. Then I have to show that probability that psi x equal to 0 is 1, right? That is what I have to show. What does that mean? That means what is expected to psi x? Psi x can take value from 1 to theta, right? Summation x equal to 1 to theta. Psi x into 1 by theta is 0 for every theta belonging to theta. Right? This theta goes away, so what does that mean is summation x equal to 1 to theta. Psi x is 0 for every theta. For every theta in theta. Theta in theta is 1, 2, 3, so on. So I first put theta is equal to 1. Theta is equal to 1, what does that give? Because it is true for every theta, so it should be true for theta is equal to 1 also. So theta is equal to 1 only gives me summation x equal to 1 to 1 psi of x is 0. So that means psi 1 is 0. Right? Theta is equal to 2. Summation x equal to 1 to 2. Psi x is 0. That means psi 1 plus psi 2 is 0. But psi 1 is equal to 0. I've already proved that that means psi 2 is 0. Theta is equal to 3. Summation x equal to 1 to 3. Psi x is 0. So that means psi 1 plus psi 2 plus psi 3 is 0. But psi 1 and psi 2 I have already proved to be 0. So psi 3 is 0. So by induction, because theta can take any positive integer value, psi of I is 0 for every I is equal to 1, 2, and so on. So what is the probability that psi x equal to 0? Under theta, psi x can take value, yeah, psi 1, psi 2, psi 3, and theta. So that means under theta, what are the values psi can take? Psi x, psi 1, psi 2, psi theta. But each of them is 0. I have shown that. So this will be 1. Whatever theta you take. Because I have shown that psi 1, psi 2, psi 3, everything is 0. So in particular, psi 1, psi 2, psi theta, for any fixed theta would be 0. So this proves that psi is complete. Now note that if I'll show you the hint for the second one, it holds for everything. Suppose it was not happening for theta is equal to 2. So for example, m0 was 2. I'll give you a hint. If m0 was, let us say 3. So if for part B, I'm saying, suppose m0 was 3, then I know that this holds for everything except for theta is equal to 3. So that means I know psi 1 is 0. Psi 1 plus psi 2 is 0. So psi 2 is 0. And then what I know is psi 1 plus psi 2 plus psi 3 is 0. No, psi 3 I do not know because theta is equal to 3 is not there. M naught is 3. So that is not there. So what I know is psi 1 plus psi 2 plus psi 3 plus psi 4 is 0. And then psi 1 plus psi 2 plus psi 3 plus psi 4 plus psi 5 is 0. Now, because psi 1, psi 2 I have already proved that, this only implies that psi 3 plus psi 4 is 0. Now here, what it means is psi 1, psi 2 I have already proved 0. Psi 3 plus psi 4 is anyway 0 by this thing. So this implies that psi 5 is 0. So from here onwards, any of the psi's would be 0. But about psi 3 and psi 4, the only thing I can say is psi 3 plus psi 4 is 0. So I can choose a function such that psi 3 is minus 1, psi 4 is plus 1, and all others are 0. Right? So this gives me a hint. So in fact, for M naught, this I'm showing for M naught is equal to 3. In general, you can look at what is there happening for M naught. So let psi of t is minus 1 if t is equal to 3, 1 if t is equal to 4, and 0 otherwise. Then what is expected value of psi of x? This would be 0 for theta is equal to 1, theta is equal to 2, theta is equal to 3, it will not be 0. Theta is equal to 3 also it would be 0 because psi 3 plus psi 4 is 0. 4 and everyone. But what is the probability that psi x equal to 0? Which would be same as 1 minus probability that x belongs to 3, 4. And under theta naught, so this probability x3 is equal to 4, this is not equal to 0, right? Because these would be probabilities less than 1, right? This would be 1 by theta, 1 minus 2 by theta. Is that clear? Because psi is not 0 throughout. Just because you removed one of the point M naught, the only thing you are getting is psi of M naught plus psi of M naught plus 1 is 0. Not everything is 0. And that is the reason why. And that helped us in constructing this function. And these are functions says that expected value of psi x is 0 for, there will not be a theta is equal to 3 here, theta is equal to 1, 2, 4, and so on. But what is what probability psi x equal to 0? 1 minus probability x belongs to 3, 4. And what would be that? Each of them so it would be 1 by theta, right? Which is not 0 for every theta. Right? Is that clear, or should I do it for more clearly for general M naught? Just look at, I showed it for M, sorry, 3. So let us look at expected value of psi x is 0, right? For every theta belonging to theta minus M naught, right? That means for every integer other than M naught. This is same as summation x equal to 1 to theta psi of x, the corresponding probability theta is 0 for every theta is equal to 1, 2, except M naught. So that means M naught minus 1, M naught plus 1, M naught plus 2, and so on. That means summation x equal to 1 to theta psi x is 0 for every theta, so on. So theta is equal to 1 gives me psi 1 is equal to 0. Theta is equal to 2 gives me psi 1 plus psi 2 is 0. So, and that would give me, so psi 1 plus psi 2 is 0. That means psi 2 is 0. I can go up to theta is equal to M naught minus 1, gives me psi1 plus psi2 plus psi m naught minus 1 is 0. And all previous are 0, so psi of m naught minus 1 is 0. Theta is equal to m naught I cannot take because my parameter space does not contain m naught. So I go to the next one, m naught plus 1. So it is psi1 plus psi of m naught minus 1. Right? And then plus psi of m naught plus psi of m naught plus 1 is 0. These all are already 0 in the previous steps. So this only says that psi of m naught plus psi of m naught plus 1 is 0. Then I can look at theta is equal to m plus 2. It will be psi1 plus psi of m naught minus 1 plus psi of m naught plus psi of m naught plus 1 plus psi of m naught plus 2 is equal to 0. What does that mean? Psi1, psi m minus m naught minus 1 are already 0 up to over here. This gives me psi of m naught and psi of m naught plus 1 is equal to 0. So psi of m naught plus 2 is equal to 0. So that means I can keep on going. So this says psi of I would be 0 for I not equal to m naught and m naught plus 2. Right? Because psi1, psi2, psi m naught minus 1 is 0 and then psi m naught plus 0. And psi of m naught plus psi of m naught plus 1 is 0. So I can choose. This suggests that I choose psi says that psi of x is 0 for x equal to x is equal to 1, 2, so on, x not equal to m naught and m naught plus 1, right? This will be m naught plus 1. Minus 1 if x equal to m naught, plus 1 if x equal to m naught plus 1. Then what happens? Then if you look at expected value of psi x would be 0 for every theta belonging to capital theta minus m naught, right? Because that is what I want. But what is the probability psi x equal to 0? Probability psi x equal to 0 is only that probability that x belongs to 1 to so on except m naught and m naught plus 1, which is 1 minus probability that x belongs to m naught or m naught plus 1. And that will not be 0. Because psi x can take value minus 1 and 1 if x is m naught and x is m naught plus 1. So if theta is greater than equal to m naught and m naught plus 1, this probability would be 2 upon. So that's the crux of the solution. Yeah, any other doubt anybody has?
No, sir, it's okay. Thank you.
Okay, then if anybody wants to stay back, I can still stay back to clear doubts. Others who want to leave, have other engagements, they may leave. But if anybody wants to stay back and discuss still some of the doubts, I would be glad to clarify those doubts.
Sir, one general question.
Yeah.
Sir, suppose for a distribution like normal theta 1 where factorization can be done easily. Sir, here we can say that summation xi or x bar is sufficient for theta.
Right.
Sir, in such a case, if the question demands that show that the order statistics x order 1 up to x order n is sufficient, sir,
Yeah.
can we just factorize this and show that x bar or summation xi is sufficient and then say that this summation xi is a function of the order statistics, so the order statistics is also sufficient? This logic
Yeah.
will do.
Yeah, that is perfect, correct logic. Perfect.
Okay,
correct.
sir. Okay, sir. I mean, we can go this way.
Unless you have been asked to show that using factorization theorem so that x1, x2, xn is sufficient. If you have been asked to just show that order statistic is sufficient, your argument is perfectly fine. Unless your question says that no, use factorization theorem to show that order statistics is sufficient.
Sir, in such a case, means how to arrange in the factorization form?
No, that you can write down. This X bar itself you can write down because you have
In
anywhere.
that form only. Achha, okay.
Yeah, write down
Okay.
that X bar, whatever you have written down in the factorization theorem, this X bar, that you can write down as summation I is
Summation
equal to
X
1
order
to X order statistics I by n.
Oh, okay,
That's
okay,
all.
sir. Okay, sir. Okay, sir.
This
This
is a
must
function of
change.
X1, X2. This is a function of X1, X2, Xn.
Okay, okay, sir. Okay, sir. Thank you.
Yes, any other doubt?
So problem number 12.
Problem number 12. Okay, so let us look at in the Cauchy case, you have to find it out. Minimal sufficient statistic. Right? So for Cauchy case, so I look at for sample points. X and Y. What is f theta x upon f theta y? Can be g theta x upon g theta y. Which is product of 1 plus yi minus theta whole square divided by product I is equal to 1 to n 1 plus xi minus theta whole square. Is that okay? This
Yes,
is
sir.
what this is what the f theta x and I have to see under what condition it is independent of theta. So it is independent of theta if and only if. What happens? Product I is equal to 1 to n 1 plus yi minus theta whole square divided by product I is equal to 1 to n 1 plus xi minus theta whole square. This should not depend on theta. So that means it should only depend on x and y. So it is c of x of y for some function c. Is that okay?
Yes, sir.
Because it says it should be independent of theta. So what does that mean for every theta? What does that mean? That means product I is equal to 1 to n 1 plus yi minus theta whole square is same as cxy times product I is equal to 1 to n 1 plus xi minus theta whole square for every theta belonging to minus infinity to infinity. What is the left hand side? If you consider all the product, each product has a theta square, right? With a coefficient 1. And when you product n times, the largest power of theta would become theta to the power 2n. So it is a polynomial. Just one second. Hello. एक मिनट आ रहे हैं, हम क्लास एक मिनट लेने जा रहे हैं. This is a polynomial of degree 2 to the power n, right? What is this? This is also polynomial of degree 2 to the power 2n. So two polynomials are agreeing on whole of real line, but a polynomial of degree n can have at most 2n roots. So one way is all the coefficients would be same. I can compare the coefficients. The coefficient of theta to the power 2n over here is 1. Sorry, cxy, and coefficient of theta to the power 2n over here is 1. So this would imply that cxy is 1. Is that okay?
Sir, can you
Because
explain this line?
Because two polynomials are agreeing on an interval,
Okay.
right? I've told you, power series, then the coefficients should match. So here
Yes,
the
sir.
coefficient of theta to the power 2n here is cxy. The coefficient of theta to the power 2n here is 1. So that's
Yes,
why
yes,
the
sir.
coefficient of theta power 2n should be same on both the sides, because you know that if two polynomials match in an interval, then their coefficients have to be same. So
Yes, sir.
cxy is 1. So once you have proved that cxy is 1, what you conclude is product I is equal to 1 to n, 1 plus yi minus theta whole square is same as product I is equal to 1 to n, 1 plus xi minus theta square. Is that okay?
Yes, sir.
Now, this is a polynomial of degree 2n with roots. What are the roots of this? Yi minus theta whole square is equal to 0. So yi minus theta whole square is minus 1. So yi theta is nothing but, yeah. So what is the root? Theta
Y,
1 plus minus square root of I, right? Right? Sorry, theta
no, plus minus I.
plus minus I. So it has two n roots, and all of them are these roots. This also has the same roots. Not theta I. Actually, the roots are not this. Roots will be in terms
Yes,
of
sir.
theta.
Y plus minus.
Huh?
Y plus minus.
Theta minus.
Roots.
Yeah, roots yi
Hmm.
plus minus
I.
I, right? This would have roots xi plus minus I, right? 2n. Now you have two polynomials which are same, so their roots should be same, right?
Yes, sir.
That means as a set, yi plus minus 1 should be same as xi plus minus 1 as a set. Now if I'm saying that as a set, a1, a2, a3 is same as b1, b2, b3, what does that mean?
Yeah. A1 is
They
equal
could be in different orders. So what I'm saying is if you arrange them in an increasing order, then they should match, right? Then only
Yes,
it
sir.
can happen. So that means their order statistics should be same. So that means yi should be same as xi, or I is equal to 1 to 8. Right? Because the set 5, 9, 2, I'm saying this set is same as 2, 5, 9, 2, 9, 5. Right? But as I said, they are same, but if you arrange them in increasing order, 2, 9, 5, the smallest one over here would be same as smallest over here, second smallest over here would be same as smallest over here, and so on. So that is what I'm saying. So this set is same as this. So plus minus goes away. So that means as I said, y1, y2, yn would be same as x1, x2, xn, which means yi should be same as xi. Does that clarify?
Yes, sir.
Now similarly, for the double exponential, your f theta x upon f theta y would be half gets cancelled. So he e to power summation I is equal to 1 to n mod of xi minus theta minus summation I is equal to 1 to n mod of yi minus theta. Is that okay? This is independent of theta. This would be independent of theta if and only if this is independent of theta. Right? Because if that depends on theta, then e to power that would also depend on theta. So that means summation xi minus theta minus summation I is equal to 1 to n mod of yi minus theta is same as some function depending on c of x and y. Now here every sum is there, so I can write down this as summation I is equal to 1 to n mod of xi minus theta minus summation I is equal to 1 to n mod of yi order statistic minus theta cxy for every theta. So suppose order statistics are not same. First I'll prove that x1 is same as y1. Suppose x1 is not same as y1, and without loss of generality you can take x1 to be less than y1, right? So what happens? X1 is over here, Y1 is over here, and for every theta you have this quantity. So in particular, this would hold for all theta less than X1. Or theta lying between, for all theta lying between X1 to Y1. For all theta lying between X1 to Y1, what is this quantity? The first term would be theta minus X1. And remaining terms would be so you can just try to show that now by taking theta in different ranges. You can try to show that each of them have to be same as. If X1 is not same as Y1, you can always choose something in between. Is that okay? You see, I'm saying you try to prove one by one. First, try to prove that claim is X1 is same as Y1. And you prove it by contradiction. On contrary, suppose X1 is less than Y1. Because there is a symmetry in X and Y, you can, without loss of generality, assume X1 less than Y1. So you have X1 over here, Y1 over here. So what I do is, there may be X2 somewhere. So I choose X1 smaller than X2 and smaller than Y2. So I choose theta between X1 to minimum of X2 and Y2, right? That means theta should be bigger than X1, but it should be minimum smaller than Y1 as well as smaller, should be smaller than Y1 as well as smaller than X2. Then what does this quantity says? Sorry, this quantity. The first term would be nothing but, so theta is over here, so theta minus X1. But theta is bigger, is smaller than rest of them, so it would be summation I is equal to 2 to n. Sorry, this would be theta minus X1, yeah. And for rest of them, xi is bigger, so xi minus theta. Minus, what would be this quantity? Here, everything is bigger than, each of the yi is bigger than theta. So it would be summation I is equal to 1 to n. Yi minus theta. For every theta in this interval. Note that this is a non-empty interval because x1 is smaller than y1. So I've taken just interval as, and x1 I also know is smaller than x2. So I can take the interval from x1 to minimum of x2 and y2. So what is this? Over here. Yeah. So from here, if you look at 2 to n, theta would get cancelled. And 1 theta will make it 2 theta. So you get 2 theta minus some terms involving x and y is same as cxy for every theta. But that cannot happen because this is an interval, and in interval this cannot be a constant function because theta is varying. So you get a contradiction. So x1 is same as y1. Then you can show that x2 is same as y2, and recursively you can show that x1, x2, xn is same as y1, y2, y. Is that
Okay,
clear?
sir.
Just try to see it, and if you work out of your own, it will be much clearer. Is that okay?
Yes, sir. And how to show that this statistic is complete?
This is not complete. I had said no, because here data is one dimensional, parameter is one dimensional, and your statistic is coming out to be
Oh, n-dimensional, yes, sir.
n dimensional, so it will not be complete. So that means you have to find some function of x1, x2, xn whose expected value is 0. All right?
Yes, sir.
Whose expected value is 0, and then you are there. So in fact, for Cauchy, I can look at some, you see, movements don't exist for Cauchy. So I can look for some statistic over here. But movements of order statistics exist. So I can find expected value of x1, you can so always exist. Right? expected value of x1 would always exist. In fact, expected value of x1 minus x2 would always exist. And what would be expected value of x1 minus x2? Is it going to depend on theta? No, why?
No,
Because
it is location family.
yeah, so x1 minus theta, xn minus theta, its distribution does not depend on theta, which is y1, y2, yn. And so expect x1 would be, so x1, x2, xn. This distribution does not depend on theta, so the same as y1 plus theta, yn plus theta. So this would become expected value of y1 minus y2. So this does not depend on theta, so this would be some constant c. So that means expected value of x1 minus x2 minus c is 0 for every theta. But what is the probability that x1 minus x2 minus c is equal to 0? x1 minus x2 are continuous variables. So they take a fixed value, that probability would be 0. Whereas for completeness, it should have been 1. Is that clear? So the only thing here you have to show that these order statistics expected value exists, because for Cauchy, the tricky situation is expected value of xi's don't exist.
Yes, sir.
Right? I have to go now, but if you are keen, you can just drop me an email. We can fix up some time. Tomorrow morning, afternoon, I am busy, but tomorrow morning I can fix up a time with you.
Okay, sir.
Just you can drop me an email and then we can meet. Is that okay?
Okay, sir.
Yeah. Okay.
Yes, sir.
So I'm just leaving the meeting right now because I have to go somewhere right now. Is that okay?
Sir,
But drop me an email
sir.
if you want to discuss. Yeah.
Sir,
Yeah.
can you upload the solutions for assignment 3 today?
No solutions I don't have right now prepared.
Okay, sir. Okay, no problem, sir. Thank you.
Yeah.